Hello. Today we talk about micro frontends and authentication in the world of micro frontends as well as in the world of microservices. And for this, I have a guest with me, namely Philip. Hi, Philip.
Hi, Manfred. It's a pleasure to be here again because I've been here before, right? At least once, but maybe even I don't remember.
Yeah, I
We've done a
think
lot of things
twice. I
together,
think
so
we did such an interview twice. And
all
today
right.
we have a very focused topic, namely, as mentioned, micro frontends and authentication.
Yeah, well, we're gonna talk
Awesome.
about authentication. All right, sure. Absolutely. Not only about micro front ends as well, but just about browser-based applications and authentication, which is well getting a pretty complicated topic, if you want to call it that. So yeah.
Yeah, I feel you. So, what is your turn on doing authentication for micro frontends and microservices?
Do it. um, yeah, let me elaborate a bit because yeah, we obviously need authentication. Maybe let me paint a landscape a bit. So honestly, we don't care about authentication. As in, authentication is something we do, but it's a means to an end, and the end is authorization. In the end, we want to make calls to a backend service, an API, whatever, and that API needs to make some authorization decisions, and that's really what we care about. And to make that decision, we need to know who's making the call, like which user on behalf of which user is the front end acting, and that's essentially where authentication comes into play. And that is a pretty complicated topic, and we can talk about everything authentication wise, and we would still be here somewhere around Christmas evening. Well, we're recording this at Christmas, so that's where we would be. But today, let's talk about front end specifically, micro front ends and non micro front ends for that matter, browser based apps. And there are also two aspects. One aspect is how do you get that information? Like you need some information representing the user authentication state. That's one thing you have to do. And the second thing you have to do is basically how do you keep track of that in the browser? Where do you keep it? How do you make sure it gets sent to the right backend service and so on? And that is a massively complicated topic. I know that's not very useful advice. So saying it's very complicated. So what's the current best practice today? Well, for the getting the information representing that authentication state today, the best practice would be OAuth. That's essentially what OpenID Connect and OAuth do. So with OIDC, you would authenticate the user, you would learn who the user is, and then with OAuth, you get an access token. That access token represents the authority of the client to contact an API on behalf of the user, and that would be the best practice approach right there. That's just the general setup. All right. And then how do you keep track of that in front ends, in micro front ends, in normal Angular applications? Well, that kind of depends on what you're building, how you're structuring the application, how much shared state you want to keep, and so on. And I can't really give an answer to that question because I only have a couple of options, and usually it takes some intimate knowledge of what you're trying to build to assess which option works and which option doesn't. And yeah, it's not something I can just shake out of my sleeve, as we would say in Dutch, right here in the interview. So that's yeah, that takes a bit of nuance and looking at different options. Does that make any
Mhm.
sense at all?
Yeah, totally. So let me pin it down to some options. So one option I've seen frequently in the past is sending an access token to the browser. And another option is keeping it on the server side in such kind of reverse proxy. If you want to sell your reverse proxy for a higher price, you need to call it security gateway. This is what I learned. So, what do you think about those two options?
Do you want to buy my security? No, I don't have a security gateway.
Okay, what a pity.
Yeah, what you're describing here is actually that's even a more advanced pattern. That's what we often call a backend for front end pattern or reverse proxy, authentication proxy. The thing has a couple of different names. And what you would have there is instead of having the front end talking to the API directly, you would add like a middle layer somewhere in between that's closely coupled to the front end, and the front end just talks to that reverse proxy, that BFF, and the BFF will handle a lot of the dirty authentication details. In that case, the story becomes quite interesting. I'm a big fan of that pattern. Let me start with that. I'm a big fan of that pattern because the security properties are significantly better than if we have raw OAuth tokens, if you want to call it that, in the browser. Because browser-based apps have some security issues. That's why we do a security workshop for Angular apps. And if something goes wrong and you're just using OAuth within the front end, using one of the libraries, then there might be some issues there that you need to take into account. So one of the solutions there is using a BFF. And there you move the token handling and the token storage and all of that to a backend component. It gives you much better security properties. And honestly, it makes the front end a lot simpler as well, because now the front end just calls that BFF, that reverse proxy or security gateway, if you want to call it that. I wouldn't call it that, but if you want to, then sure. Calls that BFF. You can keep track of state using a simple cookie, because usually everything works well within one domain. Simple cookie is present. The BFF knows how to translate that cookie into tokens, makes the call to the actual API, and the API can make some authorization decisions. Yeah, that's an awesome pattern. So if you can go for that, do it. Any security sensitive applications should definitely consider using a pattern like that. Sure.
Mhm. So you told us before that an access token in the browser might not be the best idea because the browser is no safe place. But now you're telling us we can go with a cookie. So why is a cookie more secure than an access token in the browser?
Um, it's not necessarily that the cookie. Again, it's not a. This is a hard interview. There's no simple answers to the questions you're asking me here. So the simple answer is it's not that much different, but there are a couple of scenarios that actually do make a big difference. First of all, if you have an access token in the browser that you've obtained as a client application using the authorization code flow with your library, for example, Angular OAuth OIDC, you would basically, if you become victim to cross-site scripting, malicious JavaScript in the app, the attacker would be able to request fresh tokens as well. So basically, there's no restrictions to the attacker getting hold of raw access tokens, raw refresh tokens, and extracting them from the application, shipping them off somewhere else, and abusing them for a very long time. Usually, we're talking about hours of abuse here. So you can keep tokens alive for 8 hours, 12 hours, something like that, and that would be a massive problem. And by switching to the BFF pattern where you would rely on cookies, there's nothing to extract in the browser, which doesn't solve your problem. I mean, you still have malicious JavaScript in the browser, it still executes, but now it's restricted to doing what the app can also do with the BFF. So the attacker loses a lot of power. Instead of extracting tokens and having raw, unfettered access to APIs in the name of the user, they can now just tunnel requests through the browser of the user, make the browser of the user do something. And that problem, you can't really solve that without fixing the underlying cross-site scripting problem, but it does
Mhm.
make security better and more controllable. And that's why I've been saying that security sensitive applications should consider this BFF pattern, because it makes things as controlled as possible
Mhm.
without, of course, actually fixing the cross-site scripting problem, which you should do in the first place. That's step number one.
Mhm.
Does that make
Cool.
any sense?
Yeah, totally. And if you say
All right.
cookie, I guess you refer to an HTTP only cookie because otherwise I could steal it with cross-site scripting in the browser.
Yeah, yeah. Well, it should go a bit further than that. So obviously, HTTP only is good. Yeah, it would prevent that cookie from being extracted from JavaScript and stolen. So that's a good thing. You should also add a secure flag to the cookie, which makes the cookie relevant for HTTPS traffic only, no plain text HTTP traffic anymore. That's good. We can add a same side attribute to the cookie to ensure it's not attached on cross-site requests, which is an attack vector called cross-site request forgery. So that's a good one. And there's also a cookie prefix, which is something you can add to the name of the cookie. In this case, I would recommend _ host dash as a prefix. So it's part of the first part of the name and then your actual cookie name. And that tells the browser to handle the cookie more securely, to be a bit more strict in how the cookie can be set and can be sent. And that would be the absolute current best practice. And that makes the cookie as secure as it can be. And that's,
Mhm.
yeah, that's as far as you can push it basically from the front end in combination with the BFF. So that's the holy grail of front end or securing authentication state in the front end when using OAuth.
Awesome. Holy Grail. I really like this. Makes me feel like Indiana Jones, you know.
Yeah, we are all searching for the holy grail. So this one is it. If you can go that far, that's actually quite good, and you're doing a great job. And then of course you can augment that with proper defenses against cross-site scripting, defense in depth with CSP, and so on. So there's a whole list of things you can do, but if you apply each step of that list rigorously, then I'm very confident that you'll have a secure application that's robust and, well, acceptable to the highest standards.
So let's come back to the idea of having micro frontends and microservices. Now, if I understand you correctly, we have this security gateway in between, this BFF or reverse proxy, as you want to call it. And does that mean that we have an access token in this gateway that is capable of unlocking, of accessing all the different microservices, all the business domains defined by them?
That depends on how you structure your underlying microservices. So from a front-end perspective, we don't care. That's the simple way of putting it. From the front end, we don't care. We just call the BFF and we'll get a response, and we're happy with that. So that's a really big step forward, as in from the front end, you don't have to worry about getting access tokens with multiple audiences or scopes. You just talk to BFF, and the BFF will take care of everything. Of course, as a developer, you also have to provide the BFF. So there's some work involved there. But you could go multiple ways. So the front end, the micro front ends just call the BFF. The BFF can either have one access token giving access to everything. That's possible. That's actually done quite often. Not really a best practice for a couple of backend security reasons. For example, if one of these APIs gets compromised and somebody gets an access token from that API, they can now use it on other APIs in the name of the user. That would be a problem. And one of the things you can do on the backend side is actually the best practice is to use a concept called resource indicators, which is an additional RFC for the OAuth world, where you can define upfront when you're requesting an access token, hey, I would like to access API 123, and they will make sure that everything is authorized and you're good to go. And then when you request a token from the authorization server, you can say like, oh, I asked about 123 before, but now I actually want a token for API 2. And then the BFF could get a token for API 2, use that token to call API 2. It's only valid for API 2. It's not going to be valid for 1 and 3. And that would be the way to reduce the authority associated with an access token. That's, again, a best practice, but to be honest, it's not used that often. But if you have the chance to use it, and look into it and definitely use it. There's some good products out there that do support resource indicators as an RFC. So yeah, that's the best practice.
Nice. So now we've talked a lot about authentication, but as you have told us before, I think it was in the beginning, just authentication does not really solve an issue. It's just a way for doing authorization. So what's with authorization in the microservice, for instance?
A big problem. That's what it is. So if you look at the OWASP top 10, OWASP is this nonprofit aiming to improve the state of web security. They have two top 10s. They have one top 10 for normal web applications and one for APIs. And in both top 10s, authorization issues are number one in that list, as in everybody's having them. They're absolutely horrible. They can lead to massive problems. So yeah, authorization is really important, and it's kind of a challenge to get right. In the world we're talking about, microservices, APIs in the backend, you're typically dealing with some kind of token. In reality, well, even though you have multiple options, in reality, it's going to be a JSON Web Token. So steps involved would be the basics, like validating the signature on the token correctly, not accepting weird tokens with things like elgnon, dealing with all of those aspects. And then, of course, using the claims in the token, like who is the user, user's ID, who is the client, maybe what authority is associated with the tokens, what permissions are associated with the tokens, and using all of these things to make very specific authorization decisions, which can go from, can the user access the functionality to edit restaurant information if we're dealing with a restaurant review app? Like, yeah, they can. If you own a restaurant, for example, you would be able to edit restaurant information, but you're not allowed to edit my restaurant, only your own. So that would mean we have to check that you have the right permissions, but also the right permissions for that specific object that you're trying to modify. And the combination of these things, like verifying the information you get from the client, making sure the user can access certain operations, and making sure they can do that on the objects at hand, those three steps, that's what makes authorization so complicated. Because, well, it's easy for us to talk about that, but implementing that is often very tricky, very detailed. And if you miss one thing, if you make one wrong decision, one misconfiguration, then you'll have an authorization issue. And we are back at the OWASP top 10, number 1, which is broken object level authorization, basically.
So does this mean that we need to add a lot of information into our tokens, like each and every restaurant, for instance, I'm allowed to modify the menu for, or is there another possibility?
Yeah, I wouldn't try that, because it's going to be very, very painful if you do that. If you start doing stuff like that, then first of all, you'll have to teach your authorization service, the one issuing the tokens. You have to teach it about all of these restaurants and permissions and all of those things. That's a nightmare, because you're basically duplicating your business logic in like a separate product. And sometimes you can't even do that if you're hosting or using a hosted solution like an Azure Active Directory or an Auth0 or whatever. There's no real way to implement that logic there. So no, that's absolutely not recommended. Second problem you often run into is like, hey, my token has gotten so big because of all the stuff I crammed into it that I can't fit it in an HTTP header anymore. And that's a very bad smell. If that happens, my first question is going to be, what the hell are you putting in that token? Because that is not how things are supposed to go. So no, what you put in the token is information about who the user is and the authority associated with the client. Like, hey, the user is, for example, Philip, user ID is 17, whatever, and he has allowed this client to act on his behalf, in this case, to manage restaurants. That's about the information you would put in a token in this specific scenario. And then the actual decisions are up to the API. So the API, I'm going to send a request to update restaurant with ID 2, and then the lookup is going to be like, which restaurant is this? Who's the owner of the restaurant? And does the owner match the user ID of the user asking for this request? And so on and so on. And that's essentially how you make that authorization decision. So that should be an API responsibility. The token should just contain the useful information about the user and the delegated authorities so that the API can make their security decisions. And that way, your API keeps everything close by. All the logic remains in the API. No need to duplicate that logic. And you actually get something that would work well in practice.
Awesome. So, as you already told us, those topics can become quite complicated. Are all of them covered by your Angular security workshop?
A lot of them, yes, sure. Most of them. We talked about a wide variety of topics here. So I would say that the front-end specific topics, so the workshop is an Angular security workshop. We're targeting front-end developers here. And we're going to talk about all the security issues related with front-ends. So the things about backend authorization decisions in APIs and verifying tokens in an API, that's stuff for a different workshop. So I'm not going to talk about that here. But if I would walk you through the workshop, we would basically start with understanding how the browser approaches security. So how does the browser make security decisions? We talk about cross-site scripting. How can you mess up Angular security in such a way that you'll have cross-site scripting vulnerabilities, which happens every time, by the way. So every time I teach this, after lunch, people come back like, yeah, we looked at our applications during lunch and we found this problem we talked about in class right here in our code base. Like, whoops. So yeah, that makes it very useful. Then we talk about defense in depth strategies, like how can we make it more secure? How can we prevent things from going wrong, even if you have a vulnerability? And then we slowly move towards this authorization topic, but from a front-end perspective. We talk about how to store information in the browser, local storage, cookies, maybe some fancy technique with web workers, all of those options, pass the review. And then we start moving towards OAuth with access tokens, like how do the OAuth flows work in the browser? What are the challenges? What are the limitations? How far can you push security in the front end, which is not that far? And then we talk about the BFF pattern and how you would implement something like that and set it up and so on. And of course, in between, we have some demos. I'm going to show some stuff. We have quizzes. Like I run a lot of Kahoot quizzes where you can play a game against your fellow students and try to snag first place. And we have some hands-on labs as well, where we actually get to attack applications and think about defenses and so on. So yeah, it's a mix of pretty fun topics.
Cool. Sounds amazing. Yeah, Philippe. So
yeah, actually, it is something we haven't talked about. But you saw the reviews from the last workshop. We ran one in November 22, I think.
And yeah, I've seen them. They have been pretty good, I guess. So people love you, I guess.
Well, I'm not sure if they love me, but they like the security workshop. Let's keep it there. My wife might watch the interview as well, so the reviews show that they really enjoy the content. They like the way it's presented. They find it very useful to actually go to their own applications and look into improving security there. So we'll put those online on the website. I think that's a good idea if we share a couple of the remarks, and we hope to see a lot more people, or a different group of people, I would say, in the next workshop, which is in we run this regularly, so check the website for the latest dates, because we have them a few times a year.
Awesome. Yeah, I will link it below.
All right, awesome. Yeah, your fancy video editing skills are way beyond my grasp. So yeah, awesome. Good job.
Yeah, I'm really good with setting a hyperlink. Yeah, I learned this in school. Okay, Philippe. So thanks for taking the time for this, for sharing your knowledge with us. And yeah, have a nice day. See you around.
Yeah, absolutely. Same for you.
Bye-bye.
Bye.